Grand Canyon. And now the Grand Canyon is 4 miles wide at its narrowest and 18 miles wide at its longest. 18 miles. That's a big canyon. And their explanation of the secular geologists is, well, I mean, it was a little bit of water, but it was for so many years and just cut down into that canyon. Well, what made the layers to be cut? The layers were a part of that pulsating phenomenon that I'm talking to you about, the year-long global flood that's laying down those layers. Now, you might say, John, how do you know that? Well, here's how I think I know it. The layers are very parallel. That speaks of rapid deposition. I was thinking about taking a 5-gallon bucket, hypothetically, of soupy mud and just sling it on the driveway. And it would leave a big smear of mud, right? Then I might come along the next day and do the same thing. And the first layer kind of dried out a little bit. So this would go on top and so on. Keep doing that. And then just take a hoe and just rake a straight line, and you'd look and see a pancake layering, much like you see right here. We do science experiments in Vacation Bible School, and one of the ones we do is the soil shake, showing how rapidly soils will settle out based on their relative density. So this is one reason, parallel layers. Uniform thickness of each layer, I just mentioned that. That speaks of rapid deposition. Absence of vertical erosional cuts. I mean, if every one of these layers is the top of the earth for thousands or millions of years, shouldn't we expect to see vertical erosional cuts? Shouldn't we expect to see topsoil? Shouldn't we expect to see evidence of past vegetation? Shouldn't we expect to see meteorite bombardment in those layers? None of that happens. These are laid down quickly. And these are the things I just mentioned, except for polystrate fossils. What is that? What does poly mean, class? Many. And straight, strata. So many layers. And here's a vertical polystrate tree that is going through several layers. Now, actually, the man that helped me fix the computer a few minutes ago, his daughter has a geology degree, and I taught college at Kilgore College for 14 years. And I looked in there one day. I decided to look at the geology books and see what they said about polystrate fossils. You know how much information I got about polystrate fossils in that geology book? Do your right hand like this and slowly bring it to your thumb. It's not even mentioned. Wouldn't that be a pretty significant feature? And they call it a VISS, or a vegetative induced sedimentary structure. Why not throw a bunch of syllables if you can, right? Well, this is that same one with a different filter. This is near Cookeville, Tennessee, a polystrate fossil. And in this picture, there's 4 of them. Look closely and you see all the yellow arrows. It's just a plant or animal fossil that goes through 2 or more layers. Definition of a polystrate fossil. Yet they're unmentioned in a geology textbook. One in Germany, one in Tennessee, Kentucky. They're not rare, but they're not real prominent either. And then fossil ripple marks on the continental divide. I mentioned that. And these are asymmetrical ripple marks, meaning what? Well, they were flowing in predominantly one direction. And the east-west water flow of the St. Peter sandstone and other layers created non-symmetrical ripple marks on the continental divide. And what I'm saying is, these are like, this is just a poor sketch, but gradual upswoop, a steep drop. Gradual, steep, gradual, steep. The flow was going that direction. And you can tell the direction of flow when you see an asymmetrical ripple mark. And the world's longest mountain range is underwater. What do we call it? Yeah, the mid-oceanic ridge. You got the mid-Atlantic and all that. Ring of Fire. The world's longest mountain range, and it's completely underwater. Our planet has experienced a severe wound. And how do we know? It's got a bad scar. It's got a real bad scar. And you see somebody that's been cut badly, and you know that's a scar from a wound. And this wires back into itself in the Indian Ocean. And I just wanted you to see that and be reminded of that and remind your friends about it that you're trying to win. These are ocean fossils from Mount Ararat that I was able to take a picture of in 2010. They were in a little community named White Oak, Texas, and they were brought there by a geologist, and we had a meeting, and so I took a picture of them.